Now let us consider the next fundamental aspect of geometry, a line segment. I have 2 points here, A and B. Suppose I want to go from A and B. What are the different routes I can take? Let me show you some routes. It can be like this. Yes, it can be like this. Of course, it can be like this too. But I would prefer one more route, this way, from A to B. So all these are different routes through which I can go from A to B. And out of all these routes, this particular distance is the shortest route. This AB is called a line segment. It is the shortest distance between two given points. It is the shortest distance between two given points. A line segment is represented by the two letters, capital letters. You can call it as line segment AB, or it can also be called as BA. Here I have another line segment. This is CD, or I can also call it as BC. This is EF or FE. So what are the properties of line segment? It has got two endpoints. In all these cases you have seen it has got two definite endpoints because it is the distance between 2 points, shortest distance between 2 points. Secondly, it can be measured. I can measure this. See, this distance EF is 9.39. You can use a scale to measure this. So these are the properties of a line segment, which is the second important aspect of geometry. After line segment, let us come to the topic of lines. Now, E and F are 2 points on this plane, and the shortest distance between E and F is called a line segment. This is a line segment. What if I extend this line from E towards this side and from F towards this side? If I go on extending on both the sides, what I will be getting is called a line. I can show you that. This is a line. So a line extends indefinitely in both the directions. Or I can also say that a line segment is a part of a line. If I take this portion out of a line, so I get a line segment. Is that clear? I can draw more lines for you. I can show you. Suppose I have a point this way. This is a line passing through points A and B. I can even show you more. This is a line passing through C and D. Okay. If you see, a line is denoted either by two capital letters or by a single small letter. I can show you that. It is represented either by two capital letters A and B here or a small letter F. In this case, it is C and D or a small letter G. Okay, is this clear? So when a line segment is extended indefinitely in both the directions, you get line. So what is the major difference between a line and a line segment? A line segment has got two definite endpoints, whereas a line has got no endpoints. It keeps on extending in both the directions. A line segment can be measured, a line cannot be measured. Okay. So these are some of the examples of lines. I hope this portion is clear to all of you. When we talk about lines, there are two things which I need to tell you. One is about the intersecting lines and second is about the parallel lines. Now let us see what are intersecting lines. I have two lines here. One is AB, another is CD. In this figure they are not intersecting, but if I do it like this, they are intersecting and they are intersecting at this point. Suppose I can name it as E. These two lines intersect at a point and the point is E. These lines are called the intersecting lines. Is this clear? Now let us see the answer of one very interesting question that is given in your book. Can more than two lines intersect at one point? I have two lines AB and CD intersecting at E. Now let us see whether we can draw any other line that passes through E or which can intersect at E. Okay. Yes, this particular line EF again passes through E. So now three lines are intersecting at the point E. Can there be any other line? Of course, you have this GE again which is passing through this point E. Now we have four lines which are passing through the point E. Here, another one, HE, the fifth line also passes through the point E. So five lines are intersecting at one point. Another one I can show, this one. Another one, this one. So I can draw infinitely many lines that pass through a single point. Here the point is E. Through E, I can draw as many lines as I like. And they are all called as the intersecting lines, and they all intersect at the point E. Such lines are called as the concurrent lines. They are called as the concurrent lines. So the answer is yes, infinite lines can pass through a point, and these lines are called as concurrent lines. Now that we have talked about concurrent lines, let me tell about collinear and non-collinear points. Three or more points are said to be collinear if they lie on the same line. I have 4 points over here, L, A, C and B. Let us see whether these 4 points are collinear. When will be these points collinear? They will be collinear if I can draw a line passing through all these 4 points. Let me show you. Here, this line F is a line passing through all these 4 points over here. So these 4 points are collinear points. Now I have got another set of points D, E and F. Let us see whether I can draw a line passing through these 3 points. Oh, this line passes through just 2 points. One is D, another is F. If I try another line, if I try, there will be another line which will pass through E and F, but it won't pass through D. So the points D, E and F are not collinear. Okay, they are not collinear, right? So in fact, I got another point M here. These points D, M and F are collinear. Now let us see whether these points G, I, J, K, H are collinear or not. So for that, let me try drawing another line. Yeah, this line G passes through G, I, J, K and H. So all these points are collinear. I also said these points are also collinear because a single line passes through all these points. This D, E, M, F, they are not collinear because E is not on this line. I hope this is clear to all of you.